Okay. So, hello everyone. My name is Andreas Kücker, and I'm very glad to be here at the conference of the Things Network. And I'm glad to meet all the enthusiastic professionals for LoRaWAN. When I first get into touch with LoRaWAN, quite exactly 3 years ago, it was immediately an exciting discovery for me. I instantly saw the big potential of this technology. Not from the technological view of a scientist, but in terms of benefit for the people. I'm always fascinated if technology can deliver an added value to the humans. And such a use case I will show you today. I live in Coburg. It's a little city in the northern of Bavaria. We have about 42,000 citizens. We have a lot of nature around us, as well as many nice historical buildings. One of our most famous citizens is Prince Andreas. He has a direct family ties to the British royal house. As you can imagine, not the center of innovation. But our company, as a subsidiary of the local utility company, is known for persistence in bringing process to the people. We deliver to 40,000 households in our region internet connectivity with glass fiber. And so we started 2 years ago to build an IoT network with LoRaWAN to support the smart cities. And we strongly believe that technology can bring a useful benefit to the people if it is applied in the right way. We started to build a local LoRaWAN network and climbed the rooftops of the highest buildings. We implemented several pilots with measuring of soil moisture, temperature, and of course, we measured the carbon dioxide in rooms, and many, many more. But the one I loved so much, I will show you now, and we bring to the handicapped people a better way to find a free, empty parking space. So we built a little smartphone application to help the handicapped people to find a free parking space in the city. There are 55 parking spaces downtown, and we have mostly single spaces, and some of them 2 or 3 spaces in a row. We thought, okay, no problem. Just take the German Bosch parking sensor and anchor them with screwing in the street. But not just yet. Complexity came into the project as we spoke to the winter services of the municipality, and they use heavy gear to clear snow on the road and would destroy the sensors which overlap the surface. So we choose another type of device from pre-NB-I, which is inserted into the tar and with a core drilling. One target and two ways with two different devices. The following progress was far away from digitalization and IoT. Scheduling, documentation, arranging 1,000 things. And we're starting setting up a list with all of the parking spaces and determining which type of sensor is suitable, in-ground or on the top of the surface. I have to visit every single parking location in the city. Then we relate each device to the specific parking location, that in our application at the end, it shows the right information at the right place. Then I stick the numbers on the devices so that the installation guys don't get confused, and so on and so on. But finally, we mounted the first devices into ground. So, drilling a hole, placing the pot into the gap with a little coating, filling the hole to the ground level, and then planning for a safe surface. That was a lot of noise and a lot of powder and handcraft. Placing the Bosch devices onto the road was, in comparison to that, quite easy. Just 3 little drillings, insert a plug, and screwing the plate on the ground, and finally the device at the top. But the dare during the installation was the varying constitution of surfaces. So cobbles or paving stones with grass between, ordinary asphalt, or in the parking facility, often concrete grounding. So mounting of the sensors was challenging the handcrafters very much, but finally they solved all the problems and did a great job. At the end, the data of the parking sensor were shown in a smartphone application. Honestly spoken, it's a responsive website optimized for small displays and smartphones. The screen shows the map of Coburg and marks the parking spaces with a green dot for the free spaces and a red dot for the occupied ones. The user can zoom and move through the application as usually. So by touching one of the dots, the application calculates the direct route from the current position in the blue circle to the desired parking space and shows a list of directions to drive to the location. We focused on a very simple user interface, which should be as easy as possible to use. The basis for that is a Python framework, which uses the Mapbox Java framework, a script library, and at the end, a Bootstrap framework, which deals all the display issues for different end devices and screen sizes. Some details to the digital background. Could I have it back? Oh, thank you. Some details to the digital background of our infrastructure. For receiving the LoRaWAN messages, we use approximately 13 gateways in the inner city, and each sensor reaches minimum 2 gateways to assure that we have the correct data at the end in the application. The payload we pass through our IoT platform, and we run an on-premise installation of ThinkSpot in our data center. And the payload is here decoded, and data is stored. And a special dashboard for monitoring to control the performance and optimize the system. So in the first weeks after release of the smartphone application, we get completely good feedback from the citizens, and they appreciate the new information to find a free parking space. So the idea to contribute a little to save fuel while reducing the traffic for searching a free parking space seems to be working. And I love to support sustainability with a digital technology and look forward for more projects in the future in that field, because I'm convinced that LoRaWAN has so many possibilities in that field and support this issue. If you'd like to have some more information about our projects, you can take a look at our project website. And thank you for your patience, and enjoy the last conference day. Are there any questions in the auditorium? Yeah. Unfortunately not. So there's no possibility at the parking lot to do that. So it should be implemented there, and then we could integrate in our application. Yeah. The sensor is sending immediately a message if the occupants changes. Wow. So we get a live message, I think, each hour, but each change is transferred immediately. The manufacturer tells us 5 till 8 years. So we started. I cannot approve this. Yeah.
How did you calculate the sensor to gateway ratio to ensure a seamless routing?
Pardon? Huh?
How did you calculate the sensor to gateway ratio to ensure a seamless routing?
In our dashboard, we see how many gateways are reached from each sensor. So we can check this. So minimum 2, most you have 3 or 4 gateways, because we have a high density of gateways in the inner city. Okay. Oh, one last. Fun. The nodes are powered with a PoE injector. From the gateways or these ones? The sensors have a battery inside. Yeah. Okay, enjoy your evening.